All right, buckle up, everybody, because today we are diving headfirst into Azure Kubernetes Service,
AKS.
AKS, for those of the know. Now, imagine building apps that can scale, like Google, like the giants.
Yeah,
That's the power of AKS. And we're going to break it down for you step by step, even if you're not a Kubernetes whiz kid yet. You don't have to be.
absolutely. I mean, we'll go beyond just like the what is Kubernetes, what is AKS, and really dive deep into why this is such a game changer.
Yeah,
Let's
exactly.
Ooh,
For developers, you know how AKS sets aside some resources, reserves them on each node? It's not just about having some extra on hand. It's about preventing those pesky performance issues. Makes everything run smoothly,
Right, yeah.
which ultimately benefits your application.
Absolutely. It's about creating that stable, that reliable environment where your app can just flourish.
Flourish, exactly. Okay, so before we go full on TikTok, can you give us a quick Kubernetes 101? Where does AKS even fit into all of this?
Okay, so Kubernetes at its core is an open source system for managing containerized applications. Think of it like, I always use this analogy, like a conductor of an orchestra.
Oh, I like that.
Right. But instead of musicians, it's coordinating all those different containers that make up your app.
So it's making sure all the pieces are playing together in sync.
Exactly, exactly. And that's where AKS comes in. It's Microsoft's managed Kubernetes service on Azure. So they're doing a lot of the heavy lifting for you,
Oh, okay.
like setting up and maintaining the infrastructure.
So instead of me trying to build my own Kubernetes cluster from scratch, I can just use AKS and
Exactly.
have Microsoft handle all the behind-the-scenes stuff.
Yeah, it simplifies things so much. Lets you really focus on what matters, developing and deploying your apps.
That sounds pretty good to me. But AKS, it's more than just a simplified Kubernetes, right? It's got its own unique architecture, its own set of features, doesn't it?
It does, it does. And understanding that architecture is key to using it effectively.
Okay, then let's break it down. What are the core components we need to wrap our heads around?
All right, so every AKS cluster has two main parts. You got the control plane and you have the nodes. The control plane, that's like the brain of the operation. It makes all the decisions, directs the traffic, everything.
So the control plane is calling the shots, and the nodes are kind of like the workers.
Exactly, exactly. Now, within the control plane, you have several key components. One, the API server. That's how you interact with the cluster. Want to deploy an app, check the status, you go through the API server.
So that's my main point of contact.
Yeah, and it communicates with another component called etcd. Now, etc., think of that as the memory of the cluster. It stores all that important config data, keeps track of the cluster's state.
Okay, so API server takes my request and et cetera, remembers everything.
Exactly.
But how does the control plane decide where my app actually runs? Like where to put it?
Okay, that's where the kube scheduler comes in. So it analyzes all the resources available on each node and decides which one is the best fit for each pod.
Wait, pods. What are pods?
Oh, good point. We're going to dive deep into pods in a bit.
Okay.
But for now, just think of them as like the basic unit of deployment in Kubernetes.
Okay.
So it's like where your containers live.
Okay, got it. So the scheduler finds the right home, so to speak, for the pod.
Yes.
What else is happening in the control plane?
So you also have the kube controller manager. That's basically the problem solver. It runs all sorts of processes that keep the cluster healthy.
Okay.
So for example, if a node goes down, the controller manager will detect that and spin up a new one to replace it.
Oh, so it's constantly monitoring and making adjustments to keep things running smoothly.
Exactly, constantly monitoring. And then you have the cloud controller manager. That one handles interactions with Azure. So it's managing storage provisioning, load balancing, all the cloud specific stuff.
So it's like the bridge between the Kubernetes cluster and the Azure world.
Yeah, exactly. So while the control plane is doing all that thinking and directing
Okay.
the nodes, that's where the action actually happens.
So they're like the workers carrying out the instructions from the control plane.
Exactly, precisely. Each node runs several key components to manage the containers and talk to the control plane.
Like what? I'm ready to get into the nitty-gritty of these nodes.
Okay, first up, you have the kubelet that's like the supervisor in each node. It talks to the control plane, receives the instructions, and makes sure those instructions are carried out.
So the control plane's like eyes and ears on the ground.
Yeah, exactly. Then there's QB proxy. That's like the traffic cop for the
Okay.
network traffic on the node.
Okay.
It manages the network rules and makes sure communication between the pods and the outside world is flowing smoothly.
All right, so kubelet's the supervisor, kubeproxy's the traffic cop. What else is happening at the node level?
All right, this is where it gets interesting. The container runtime. Now, this is the software that's actually responsible for running your containers. In AKS, the runtime is containered, a very powerful and widely used runtime known for its performance, its stability.
Container. Okay. So it's like the The engine that makes the whole containerized application go.
You could say that it's what allows your applications, all packaged up in these nice little containers, to execute, to actually function on the nodes.
Okay, so we got the control plane, the brain making the decisions, we got the nodes doing the work, but we still haven't talked about these mysterious pods.
Oh, you're right. You're right. That's where we need to dive deeper next. Remember how I said pods? That's where your containers live.
Yeah, the basic unit of deployment in Kubernetes.
Well, they're more than just containers. They're actually little self-contained units
Okay.
that can hold multiple containers that need to work really closely together.
So like a little team of containers all working towards the same goal.
Exactly. And those pods, they get scheduled and managed across all the nodes in your AKS cluster.
This is starting to make a lot of sense.
Good.
But before we get too deep into the pod world, I'm curious about how we actually organize and manage all these resources, right? I mean, it seems like things could get pretty messy with all these nodes and pods floating around.
Absolutely. And that's where namespaces come in. They're like, think of them as folders on your computer, right? You're organizing your resources logically.
Well, I could have a namespace for my development team, one for production, and so on.
Exactly. They help keep things tidy, prevent conflicts, make it easier to manage access and permissions. And there's one more organizational piece to consider, and that's the node resource group.
Ah, yes, yes, the second resource group.
That gets automatically created.
That is automatically created. What's its role in all of this?
That's where all the infrastructure resources for your cluster actually live. So the VMs, the storage, all the things that are needed to support those node and pods running on top of them.
So it's like the foundation, the bedrock that everything else is built upon.
Exactly. Keeps the infrastructure separate and organized, much easier to manage and monitor.
Wow, we've covered a lot of ground. We've got the control plane making the decisions, nodes doing the work, pods housing our containers, namespaces keeping things tidy, the node resource group providing the infrastructure backbone.
We've covered a lot.
It's incredible how much goes on behind the scenes.
It is.
But I'm ready to move beyond the individual nodes now. Let's talk about those pods and how they're managed across the whole cluster.
Yeah, you're right. It's time to zoom out.
Zoom out.
And see how pods are orchestrated across multiple nodes. Remember, pods are those basic units of deployment in Kubernetes. They can contain one or more containers.
Right.
So how does AKS decide which pod goes on which node? Well, I'll tell you, it's not just a random assignment.
Yeah, I was going to say.
There's some serious smarts going on behind the scenes.
There's got to be a system.
Yeah, and that's where the Kubernetes scheduler steps in.
Ah, yes, the scheduler.
Remember, we talked about that.
Part of the control plane?
Part of the control plane, exactly. The scheduler's job is to match those pods with the best seeded nodes based on a whole variety of factors.
So it's like a matchmaking service.
It is, yeah.
For pods and nodes.
Yeah, that's a great way to think about it.
Okay.
It considers things like the resource requirements of the pod, the available capacity on the nodes, any special constraints you might have set.
Wow, so it's doing a lot of calculations, a lot of analysis to make the best decisions.
Oh, yeah. It's constantly evaluating the state of the cluster, making adjustments to make sure everything's running smoothly and efficiently.
The scheduler sounds like a busy bee.
It is. It's always working.
It is. So it takes the pods and spreads them out intelligently across all the nodes.
It does, yeah. And it doesn't just stop there. It's also monitoring the health of the pods. So if something goes wrong,
Okay.
it can restart them or reschedule them if needed.
Okay, so it's not a one-time assignment. It's ongoing management optimization of where those pods live.
Exactly. This dynamic orchestration is one of the key benefits of Kubernetes.
Yeah, I can see why. It's almost like a conductor leading an orchestra, making sure all the instruments are playing in harmony.
Yeah.
And that the music never stops.
That's beautiful. I love that analogy. But just like an orchestra needs a score to follow, Kubernetes relies on something called a deployment to define how many pods should be running, how they should be managed.
Okay, deployments. I think I need a little more on that.
All right, so deployments are basically a set of instructions for Kubernetes on how to manage your pods.
Okay.
They tell it how many replicas of a pod should be running, how to update those pods, how to roll back to previous versions if something goes wrong.
So it's like a blueprint for managing the life cycle of my pods.
Exactly. And they're crucial for maintaining the availability, the scalability of your applications.
Okay, this is all starting to click now.
Good.
So we've got pods with the containers inside, the scheduler spreading them out, and then deployments are acting like the blueprints. It's like a well-oiled machine.
It is. And it gets even more interesting when you start talking about services.
Services. Okay, now I'm really intrigued.
All right.
What role do they play in this orchestrated world?
So services provide a way to expose your applications that are running in pods to the outside world. They act as an abstraction layer, allowing clients to interact with your pods without needing to know their specific IP address or location.
Okay, so instead of me having to keep track of all these individual pods, I could just talk to a service and it'll handle all the routing, the communication.
Exactly, you got it. Services are like the front desk of your application, providing that consistent entry point even as pods are created, destroyed, moved around behind the scenes.
That's incredibly useful.
It is, it
It
is.
simplifies networking, and it makes my applications more resilient, I imagine, to changes.
Exactly. Services are a fundamental concept in Kubernetes, and they play a key role in making your apps accessible and scalable.
All right, we've covered a lot of ground here. We went from understanding the individual components of nodes to seeing how pods are scheduled and managed across the entire cluster.
Yeah,
And now we've even touched on services acting as the front door to our applications.
we've done a lot.
It's incredible. But you said earlier we've only scratched the surface, right?
We have. There's so much more to explore. We've only just begun to uncover what's possible with AKS.
I'm already feeling like I've learned so much,
Good.
but I'm definitely eager to dive deeper.
Awesome.
What other exciting topics await us in the world of AKS?
Well, next time we'll be exploring some of the more advanced features of AKS, like scaling, networking, and storage. We'll see how AKS can really help you build truly robust, scalable applications.
Sounds fascinating. Can't wait. Okay, so last time we talked about the control plane, the nodes, but I'm ready to get under the hood of these nodes.
Okay.
What are they really made of?
Well, think of the nodes as powerful virtual machines running in the cloud. And just like you'd pick a car based on what you need it for,
Right?
Choosing the right VM size is crucial for your AKS nodes. It all comes down to resources: CPU, memory, storage.
So if I'm running a demanding application, I'd want a node with a bigger engine, so to speak.
Exactly, exactly. You wouldn't try to haul a trailer with a tiny compact car, would you? Same principle applies here.
Right?
And luckily, AKS offers a wide variety of VM sizes to fit different needs.
Flexibility is key. What about the operating system? Do I have choices there too?
You do. AKS supports several operating systems: Ubuntu Linux, Azure Linux, even Windows Server.
Oh, wow.
Yeah,
So I'm not limited to just specific types of applications.
exactly. It gives you the freedom to run what you need.
Love that. Love that. Now, let's talk about something that maybe seems a little counterintuitive at first, this whole idea of resource reservations.
Okay.
Why would AKS reserve resources on each node instead of just making them all available for my apps? It seems kind of wasteful.
Well, it's all about keeping the cluster healthy, preventing those noisy neighbor problems.
Noisy neighbor, okay?
Yeah, remember those system pods that keep everything running smoothly?
Right, right.
They need resources too.
Oh, okay.
So by reserving a small portion on each node, AKS makes sure that those system processes always have what they need to function.
So it's like having a dedicated lane on the highway,
Yes.
just for essential traffic.
That's a great analogy. Without these reservations, your critical applications could end up competing for resources with system processes, and that can lead to performance issues, instability, all sorts of problems.
Makes sense. It's better to have a little bit of a buffer than risk the whole thing crashing.
Absolutely.
So what specific resources get reserved?
So AKS reserves both CPU and memory. The exact amount, it depends on things like the VM size, the Kubernetes version.
Okay.
But it's typically a small percentage that ensures smooth sailing for both system processes and your own applications.
Okay, so it's a small price to pay for a more stable and reliable cluster.
Exactly.
What about the OS disks? We've talked about VM size, the operating system, but what about the storage where all that lives?
Oh, good point. By default, AKS uses managed disks for the operating system disks of the nodes.
Okay.
And these are persistent, which means they retain their data even if the node restarts.
So it's like having a separate hard drive just for the operating system.
Exactly, yeah. Makes managing nodes much easier. If a node needs to be replaced, AKS can simply attach that OS disk to a new VM and you're back in business.
That's pretty efficient. Anything else special about these disks?
Well, AKS also offers ephemeral OS disks, which can make node provisioning much faster.
Oh, okay. How do those work?
So instead of storing that OS disk on a separate managed disk, it lives on the local storage of the VM.
So it's like working directly from your computer's hard drive instead of using an external one.
Exactly. Because the data doesn't have to travel over the network, node startup times are much quicker. However, there's a trade-off. Ephemeral OS disks are not persistent, so if a node restarts, the data on that disk is gone.
Ah, so it's a balancing act
It is.
between speed and data persistence.
Exactly. If you're working with, short-lived workloads, maybe things that need to spin up really quickly,
Right.
ephemeral OS disks can be a huge advantage. But if you need that data persistence, stick with the standard managed disks.
Got it. So AKS gives you options depending on what you need.
Yeah, flexibility.
Flexibility, exactly. Now we touched on the container runtime earlier,
Uh-huh.
but I'm ready to go deeper on that.
Okay.
It's It's what actually runs the containers, right?
The VM is the car, the container runtime is the engine that makes it go.
Okay, so it executes the code inside the containers
Yeah.
and makes them, do their thing.
Exactly. It also handles things like downloading container images, managing resources, providing a secure environment for those containers to run in.
Sounds like a pretty complex job.
It is.
What container runtime does AKS use?
So AKS uses containered,
Containered.
which is known for its performance, its security, its stability. It's actually a key component of many container orchestration platforms, not just AKS.
So it's a trusted and reliable choice.
Absolutely. You can be confident your containers are in good hands.
Good hands, yeah. So we've got the virtual machines, we've got the operating system, resource reservations, OS disks, the container runtime. All these elements are coming together to create these powerful workhorses that are the AKS nodes.
They are.
It's fascinating how much is going on behind the scenes.
It is.
But I'm ready to move beyond the individual nodes now. Let's talk about those pods and how they're managed across the entire cluster.
Yeah, you're right. It's time to zoom out and see how those pods are orchestrated.
Zoom out.
Across multiple nodes, remember pods are the basic units of deployment in Kubernetes, and they can contain one or more containers.
Right.
So how does AKS decide which pod goes on which node? Well, I'll tell you, it's not just a random assignment.
I was gonna say.
There's some serious smarts going on behind the scenes.
There's got to be a system.
Yeah, and that's where the Kubernetes scheduler comes in.
Ah, the scheduler. We talk about it as part of the control plane.
Exactly, part of the control plane. And the scheduler's job is to match those pods with the best suited nodes based on a variety of factors.
So it's like a matchmaking service.
It is, yeah.
For pods and nodes.
Yeah, that's a great way to think about it. It considers things like the resource requirements of the pod, the available capacity on the nodes, any special constraints that you might have set.
Wow, so it's doing a lot of calculations, a lot of analysis.
It is.
To make the best decisions.
It's constantly evaluating the state of the cluster, making adjustments to make sure everything is running smoothly and efficiently.
This scheduler sounds like a busy bee.
It is always working.
So it takes the pods and it spreads them out intelligently across all the nodes.
It does, yeah. And it doesn't just stop there. It's also monitoring the health of the pods. So if a pod, something goes wrong, it can restart it or reschedule it if needed.
Oh, okay. So it's not a one-time assignment. It's ongoing management optimization of where these pods live.
Exactly. This dynamic orchestration is one of the key benefits of Kubernetes.
Yeah, I'm starting to see why.
Good.
It's like a conductor leading an orchestra, making sure all the instruments are playing in harmony and the music never stops.
That's I love that analogy.
Yeah.
But just like an orchestra needs a score to follow,
right.
Kubernetes relies on something called a deployment.
Okay.
To define how many pods should be running, how they should be managed.
Deployments. Okay, I think I need a little bit more explanation on that.
All right, so deployments are basically a set of instructions for Kubernetes on how to manage your pods.
Okay.
So they tell Kubernetes how many replicas of a pod should be running, how to update those pods, and how to roll back to previous versions if something goes wrong.
So it's like a blueprint.
Yes.
For managing the life cycle of my pods.
Exactly. And they are crucial for maintaining the availability, the scalability of your applications.
Okay, this is all starting to click now.
Good.
So we've got pods with the containers inside, the scheduler spreading them out, and deployments acting as the blueprint. It's like a well-oiled machine at this point.
It is. And it gets even more interesting when you start talking about services.
Services. Okay, now I'm really intrigued.
All right.
What role do they play in this orchestrated world?
So services provide a way to expose your applications that are running in pods to the outside world.
Okay.
They act as this abstraction layer,
okay,
allowing clients to interact with your pods without needing to know their specific IP address or location.
Okay, so instead of me having to keep track of all these individual pods,
right,
I could just talk to a service and it'll handle all the routing, all the communication.
Exactly, you got it. Services are like the front desk of your application. They provide that consistent entry point even as pods are created, destroyed, moved around behind the scenes.
That's incredibly useful. It simplifies networking. And it makes my applications more resilient, I imagine.
It does.
Yes,
exactly. Services are a fundamental concept in Kubernetes, and they play a key role in making your applications accessible and scalable.
Right. We've covered a lot of ground here. We went from understanding the individual components of nodes to seeing how pods are scheduled and managed across the entire cluster. And now we've even touched on services.
Yeah.
Acting as that front door to our applications.
We've done a lot, but there's still more to explore. We've only just begun to uncover what's possible with AKS.
I'm already feeling like I've learned so much.
Good.
But I'm definitely eager to dive deeper. What other exciting topics await us in the world of AKS?
Well, next time we'll be exploring some of the more advanced features of AKS, like scaling, networking, and storage. We'll see how AKS can really help you build truly robust, scalable applications.
Sounds fascinating. Can't wait. Welcome back, everybody. We're in the thick of it now, exploring all the ins and outs of Azure Kubernetes Service,
AKS.
AKS. We've talked about those nodes, the control plane, all the pieces working together. But now I think it's time we really get to know those pods.
Yes, the pod.
Those pods, they're kind of the heart and soul of everything, right?
They really are.
So remind me again, what makes a pod so special? We know they house those containers,
Right.
but what else is going on in there?
Think of a pod as a tiny little self-contained world for your application components.
Okay.
It can hold one or more containers that need to work together, share resources, communicate seamlessly.
So it's like a miniature ecosystem
It is, yeah.
where containers can collaborate and thrive.
Exactly. Let's say you're building an e-commerce site. You might have one container running the web server, another for the database, maybe one for recommendation engine,
Right.
all essential parts of your application. They can all live together in this pod.
Like a little team of specialists,
Yeah.
each with their own skill set,
I love that.
coming together to create something amazing.
I love that analogy. And here's where things get really interesting. Pods are designed to be ephemeral.
Ephemeral. Does that mean they have a short lifespan? Like they're
Well,
constant?
yes and no.
Yeah.
Ephemeral in this context means that pods can be created, destroyed, replaced easily without disrupting the overall application. Kubernetes manages this life cycle automatically,
Okay.
making sure your application stays up and running even if individual pods fail.
So it's like a self-healing system. If one part breaks down,
Yes.
it can just be swapped out seamlessly.
Exactly, yeah. This self-healing capability is a game changer for application reliability.
I can imagine. Yeah.
It makes your apps more resilient, less prone to downtime.
That's a huge plus. So how does AKS decide which pod goes where? We've got all these nodes
Right.
spread out, each with their own resources.
Right.
How does the matchmaking happen?
That's where that Kubernetes scheduler comes in again. Remember him? He's constantly monitoring the cluster, analyzing resource availability, making decisions about where to place each pod for optimal performance.
So it's like an air traffic controller
Yeah.
for pods, making sure they land on the right runway.
Exactly. And it considers a bunch of factors, resource requirements of the pod, the current load on each node, even special constraints or preferences that you might have set.
Wow. So it's doing a lot
It is.
behind the scenes.
But it does it all behind the scenes, so you don't have to worry about it. You can focus on building and deploying your applications.
That's good. That's good. Now, remember how we talked about those namespaces earlier?
Mm-hmm.
They help keep things organized,
Right.
like separate folders for different projects.
Exactly.
They play a key role in this podded management too, right?
They do. Pods are assigned to specific namespaces, so it provides a logical way to group and isolate them.
So I could have a namespace for, say, my development team, another for staging, another for production,
Yeah.
each with its own set of pods.
Exactly. Keeps things tidy, prevents conflict, and it allows you to control access and permissions on a granular level.
Okay, that makes sense. And then there's that other organizational element too, right? The node resource group,
Ah, yes, the dedicated resource group
the dedicated one,
for all that underlying infrastructure.
right? For all the underlying infrastructure.
That's where all the VMs, storage, other resources that are associated with your nodes, your pods, all that stuff lives.
Okay.
Keeps the infrastructure nice and tidy, easy to manage.
Easy to manage. It's amazing how AKS brings all these pieces together so seamlessly.
It is.
It really is. But with all this talk about pods and containers, I'm curious, how do we actually interact with our applications running in these pods? They're tucked away inside the cluster.
That is a great question, and it brings us to the concept of services, which act as the front door
Okay.
to your applications that are running in those pods.
Services. Okay.
Yeah.
So they provide a way to access those pods from the outside world.
Exactly. Services act as an abstraction layer, allowing clients to connect to your pods without needing to know their specific IP address or location.
So it's like a central point of contact,
Yes.
regardless of where those pods are actually running.
Precisely. They make your apps more robust, more scalable. They handle things like load balancing, making sure traffic is distributed evenly across multiple pods.
Oh, wow.
They also provide a stable endpoint for your applications, even as pods are created, destroyed, or moved around within the cluster.
This is all starting to click now.
Good.
So services provide that stable, accessible entry point
They do.
to our applications running in those tiny but powerful pods.
They do. They play a vital role in building those robust, scalable, resilient applications on AKS.
Wow, this has been an incredible journey into the world of AKS.
It has been.
We explored everything from those foundational components to the the intricate workings of pods and services,
We did.
and we saw how AKS can really empower developers, right, to build, deploy, manage these cloud-native applications
Yeah.
with remarkable efficiency and power.
It's powerful stuff.
It is, it is. I'm feeling a sense of awe
Yeah.
at the complexity and the elegance of this whole system.
It is. It's beautifully designed.
It is, but as you said earlier, we've only scratched the surface.
We have. There's a whole universe of advanced features and capabilities waiting to be explored.
Right, right.
And the best part is the world of Kubernetes and container orchestration, it's constantly evolving.
It is.
There's always something new to learn, something new to try out.
So for our listeners, we encourage you to continue exploring, keep learning, keep pushing the boundaries of what's possible with AKs.
Absolutely.
It's an exciting journey.
It is.
And we're glad you joined us for this deep dive. Until next time, 2010 too.